Hi everyone, today let's move on to look at chapter 22, section 1, Newton's third law. So in the last chapter, we already looked at Newton's first and second law. So let's look at the last one. Now, imagine that you try to push against the wall. You will feel the wall pushing you back. What is that force you're feeling? Well, this is Newton's third law. If object A exerts a force on object B, then object B exerts a force on object A with the same magnitude but opposite directions. This means that whatever force you're exerting on the wall exerts a force on you as well. Since the force is away from the wall, this force stops you moving through the wall. So let's have a look at this diagram. Imagine this is a person trying to push against the wall. That means the wall will experience a force from the man, but the force is actually acting on the wall. But similarly, to stop the person falling through the wall must be exert a force onto the man, so that now the force is actually acting on the man. Can you see the difference? One of them, for this one, the force is acting on the wall, but this one, the force is acting on the man. So that means there are two different forces acting on two different objects. However, those two forces just have the same magnitude, but the opposite direction. Now, Newton's third law is also commonly stated as each action has an equal and opposite reaction. So when you do the question, please be careful. Okay, just like how we explained before using the diagram, the two forces do not act on the same object. So they do not cancel each other. Okay, so let's have a look at the diagram again. The two forces, they do not act on the same object. This one is on the wall. This one is on the man. So they do not cancel out with each other. Okay, so let's have a look at an example. So here it says, a man pushes the wall with a force of 20 Newton. What is the magnitude and the direction of the force acting on the wall? Okay, so, well, if there is a 20 Newton force being pushed onto the wall, that means the force here would be 20 Newton. So for part A, the force is 20 Newton, but this time because it's acting on the wall, so it's kind of pushing into the wall, or in other words, the direction would be towards the right-hand side. And here, or maybe we should say right-hand side towards the wall. Part B, what is the magnitude and direction of force acting on the man? So by Newton's third law, this force will be exactly the same as 20 Newton, but will be in opposite direction. So this time it will be going towards the left-hand side, and that's towards the man. Okay, so just simple as that. Right, let's look at another example. Okay, so here it says, John pushes a box of 5 kilograms across the ice with a 30 Newton force. John does not move at all, but the box starts to accelerate and move across the ice from rest. Assume there is no frictional force. Let's find the acceleration and how far the box is going to travel in 2 seconds. Well, so in this case, there are two objects. One of them is John and the other one is the box. Now, the question is mainly talking about the box. And as we can see here, John does not move at all, so it means there's no acceleration. So that means let's focus on what is happening to the box. So let's start by drawing a diagram. So this is the box, and what do we have? So here we have a 30 Newton force. Let's imagine it's towards the right-hand side. Okay, now part A, we want to find the acceleration. So, well, we have to use Newton's second law, which is F equals to ma. And this is because we already know the force. So F is 30. We know the mass, which is 5. Now we can work out the acceleration, and that would be 6 meters per second squared. All right, so that means the box will be moving towards the right-hand side with acceleration of 6 meters per second squared. Let's look at part B. Find how far the box is going to travel in 2 seconds. So now we know the acceleration, we know the time, we need to work out the distance, so that would be super. So let's write out S, U, V, A, and T. S is the distance we're looking for. Let's put question mark there. U is the initial velocity, and in this case, it says the box starts from rest, so that would be 0. We don't know the final velocity, so let's cross it out. A is 6, and time is 2. So which super equation do we need to use to find out S, and it does not involve V at all? Hopefully you realize the formula we need would be S equals to UT plus a half AT squared. So S will equals to 0 times by 2 plus a half times by 6 times by 2 squared. So S equal to 0 plus a half times by 6 times by 4, and 6 times 4 is 24, half it, that will be 12. So S equals 12 meters. This is how far the box is going to travel in 2 seconds. Okay, so hopefully you don't find this question that bad. Now let's look at another question. Right. Okay, so in this question, it says 2 skaters are standing on ice. They push against each other and start to move away from each other. Skater A, whose mass is 75 kilograms, moves with acceleration of 3.7 meters per second squared. As you can see in this diagram, skater A is going to move towards the left-hand side. Skater B's mass is 63 kilograms, and let's look at the diagram. If there's a force pushing onto skater B, that means skater B will move backwards towards the right-hand side with an acceleration. So, assuming that any frictional force can be ignored, let's find the acceleration of skater B. Okay, so let's focus on skater A first, because we know skater A's mass is 75 kilograms, and we also know the acceleration. So I think what we need to do is to firstly work out the force acting on skater A. And we will need to use F equals to ma. And let's put a capital A for the mass and capital A for the acceleration. So F will equals to the mass for skater A is 75 kilograms. Acceleration is 3.7. So the force come out to be 277.5 meters. Now this will be the same force acting on skater B. So now let's look at skater B. Again, we have F equals ma, and you can see that for the capital F, I didn't really use a capital A or capital B because it's the same force. However, the mass will be different, so let's put B and the acceleration A with a little b there. So now we have 277.5 equals to, this time the mass for skater B is 63 kilograms, and let's work out the acceleration. So the acceleration for skater B come out to be 4.40 meters per second squared, to 3 significant figure. Great. So hopefully you have now understand Newton's third law, and it will be able to use it to work out force or acceleration. Now, let's give some time to do some exercise by yourself. Here's the exercise 22A. When you do the exercise, please start by drawing a diagram and then label the force or acceleration onto the diagram. Think really carefully. Now, as we said at the very beginning of this video, the forces will be acting on two different objects, not the same object. So be very careful when you draw the diagram. You may draw two diagrams depending on the question. Here are question 1, 2, and 3. Question 4 and 5. And here are the answers.